Good. One of Chioma Okafor.
Yes,
Can
I
you hear
can
me?
hear you.
Okay, you are welcome to the Grivet program. Uh, will be our course is hydraulic systems in waste management, and my name is Mr. Deji. I'll be taking you through the course today and tomorrow, or today and Thursday. Then we have a Friday and Saturday as our practicals. Is that clear?
Don't we have a commercial coming up?
Can you all see my screen?
Yes, sir.
Okay, good. So the course is hydraulic systems in waste management, the Green Vet Africa program. So it's to build capacity for the Nigerian and Ghanaian participants. And as you can see, the contents, things that we are going to look at between today and Thursday, we look at application of hydraulics in waste management, talking about the compactor, the baler, the garbage truck. What is hydraulics technology? Merits and demerits of using hydraulics technology. Then we have a quiz, that's to see that we are really learning. Then we move to structure of the hydraulic system. We look at the hydraulics power unit, another quiz. Then something that we can check on the YouTube. Then we look at valves. We look at directional control valves, another quiz. We look at non-return valves, flow control valves, pressure control valves, another quiz. We look at the hydraulics unit, then another quiz, and we end it. Are we clear? Hope
Yes,
everybody
sir.
is following. Okay, good. When I need response, you respond so that I know that I'm impacting knowledge. So now, looking at hydraulic systems in waste management, examples of the hydraulic applications in waste management is the garbage truck, the baler, and the compactor. These are applications where you really find hydraulics, particularly in the garbage truck. The hydraulics is of great use there. So there is a video showing the hydraulic system being used for the baling process. Now this is the garbage truck. That's the hydraulics internally showing the red. So It's good we have you seen the baler and the garbage truck? I need responses.
Yes, sir.
From the video, you could see that process of compacting. That's for the baler. Not only compacting, also that the material is tied up, ready for proper transportation. And we could see the compartment of the garbage truck. You can see the cylinders, though for some that know, and for those that know, you get to know about it later. So for compaction on the garbage cross, so that what waste can be properly stored before being transferred to for further processing. Now, what is hydraulics technology basically? It is using pressurized fluid to perform mechanical work. That's the main thing about hydraulics technology. You have hydraulics as a science, which is the study, of the use of oil. That's what hydraulics as a science is. And that one you have it divided into two: hydrodynamics, study of fluids in motion, and hydrostatics, study of fluid at rest. But our focus is hydraulics technology. That is how you use pressurized fluid to perform mechanical work. And the main thing is that hydraulics technology is based on Pascal's principle. We are going to look at that later. But it is pushing on a confined fluid, a fluid that has been confined in a vessel. Usually, most times, what is used is petroleum oil to do work. So, in the hydraulics system, the input component is the pump. It is the pump that generates the pressure, while the output component is the actuator. When you say actuator in hydraulics, you are talking about the devices that actually does the work. Talking about the cylinders or where hydraulic motor is used. That is hydraulics technology for you. So, why use hydraulic system? What is the beauty? What are the merits? What's the advantage of using hydraulics technology? The most important advantage hydraulics technology offers you is that it is a force multiplier. With small components, you can generate large forces. Take for example, the hydraulic jack. With the hydraulic jack, you can lift a vehicle, and which is a great advantage once the fluid is confined. Another thing for an hydraulic system is that it is self-lubricating. Because you are using mineral oil, you don't need to get extra oil for lubrication. So the oil itself will lubricate the system. One other advantage of the hydraulic system is that because liquids are scarcely compressible, the motion is smooth and the motion is even. And not only that, the motion can also be easily reversed. Another advantage is the hydraulic system has favorable heat dissipation. Now, the hydraulic system is designed such that it can absorb a lot of heat without the oil breaking down or changing form, at least within proper working temperature. One other advantage of the hydraulic system is that you can load it to the maximum and you can start under maximum load. You don't need to do multi-stage loading. So those are the merits of the hydraulic system. There are some other merits, but these are key merits about the hydraulic system. Now, there is no system that has merit, and when you look at it critically, that system will also have some demerits. So now, what are the demerits of using the hydraulic system? Now, because you are using waste oil, at some point, waste oil causes what? Pollution. Waste oil causes pollution. Not only that, oil attracts dirt. Oil attracts dirt, which is another disadvantage. Another disadvantage of the hydraulic system is that when there are accidents, a lot of hazard results, which could cause breakdown of the machine or as well injury to personnel. Another aspect of the hydraulic system that is a disadvantage is when uh, excessive pressures come to play. When excessive pressure come to play, hazards, dangers will occur. either to the personnel or to the hydraulic component, which is sometimes cannot be palatable. Now, those are the merits and demerits of using the hydraulic system. Am I communicating? I need to get responses.
Yes, you
Yes.
are.
Okay, good.
Yes.
Now, so now it's time for the quiz. It's time for the quiz. And I want people to eh, actually answer and participate. So these two hydraulic machines used in waste management. Let me say Chioma Okafo should answer that. Chioma Okafo, are you there? Let me get an answer from Chioma Okafo.
I can't even see I can't see the screen.
Why? What can you not see there? Okay, but you can hear. I said list two hydraulics machine used in waste management. If you cannot see, then you could be able to hear. Choma, you can hear me now. Okay, Mr. Michael Odinuta, answer.
Good afternoon, sir.
Good
So
afternoon.
basically,
Yes,
the baler
yes,
uses hydraulic.
yes,
The
yes,
tractor machine uses hydraulic. The waste truck itself
yes. The
uses
garbage
hydraulic
truck.
system as well. The garbage truck, yes.
Thanks so much. Now, good. I'll need another person. Okay. So, Mr. Falano, hydraulics technology involves using dash to do work.
That is the pressure.
Mm, may polish it.
Okay. That
Using
would
dash,
be
yes.
using fluid pressure to do
Ah,
work.
now you have done it better. Using fluid pressure to do work. Now, why? Because the fluid are confined in a space, and when you apply pressure to that fluid, that pressure can be transmitted throughout the fluid and is at right angles, and the pressure is equal in all areas. So it is that concept that forms the foundation of hydraulics technology. So hydraulics technology involves using pressurized fluid to do work. So now I need Mr. Sunday to answer this. Mention one main advantage of using hydraulics technology. Mr. Sunday Uleji, are you there?
Yes,
Yes.
one main advantage is
One main advantage, yes.
okay. It generates large forces.
Yes. Beautiful. You can see that with our small hydraulic jam, we can lift vehicles that are far, far bigger. So the main advantage of the hydraulic system is that it is a force multiplier. With small components, you can generate large forces. At this point, any question before we move to some basic principles of the hydraulic system? I'll take the silence.
Okay, can I
Okay,
ask my question?
you can, yes.
Okay, can you uh, expatiate or explain to us what you mean by that's going to the disadvantage of the hydraulic system? When
Yes.
you said uh, uh, result in accidents and all of that. Can you
Okay, now,
explain that?
okay,
Yes.
good. See, majorly, hydraulic system generates very high pressure. Now, and for every component you use in the hydraulic system, they are designed for certain capacity, certain pressure that they can handle. So when you go beyond such pressures, those components will malfunction and leading to accidents which can damage the hydraulic equipment or cause injury to personnel. And sometimes they are not very palatable. They are not very good at all. Is that clear, or you still want further clarification?
It's
So let
okay,
me give
sir.
an example. Imagine using a jack, an hydraulic jack, to lift a truck. And at one point, there is a breakdown, probably there is a leakage, and that uh, vehicle comes crashing down. What will happen? Mr. Sunday, are you with me? What will happen?
Yes, I'm with you.
So the
Yes.
resultant effect will not be good for the
Yeah.
personnel around, even for the hydraulic equipment itself. See, there is what we call pneumatics. That's using compressed air to work. And there's what you call hydraulics, using the pressure of fluid. With hydraulics, you can generate very large amount of pressures. And with that large amount of pressure, it also means when you reverse the issue, it becomes a serious damage. So sometimes hydraulics is used a lot in ports for lifting those containers. And when there is a failure and such containers do fall, they do fall on people. So, or when the components are exposed to excessive pressure, sometimes they burst and the oil will leak, and also the damage to the equipment, which can also hit a human being, causing serious injury. Is that clear? Can we proceed now?
Hello, question, sir.
Yes.
Good evening, sir. This is
Good
Umedu Achis.
evening.
I'm calling from Enugu, sir.
Oh, okay. You're welcome.
Sir, thank you, sir. You talked about that a pump is necessary to pressurize the liquid or the fluid so as the actuator to work. Now, my question
Yes.
is first, what kind of pump is needed for such
Okay.
process? One, two, like previous knowledge I had I had that there must be a primary power, primary source for a primary mover. Like
Oh, okay, good.
or
We are still
mechanical.
going to go towards those things when we get to hydraulics or power supply unit. But it's good that also maybe answer the question.
Okay,
There
no
are
problem, sir.
several
Thank
types
you.
of pump, but majorly is the gear pump that is being used a lot in hydraulics. The gear pump is the gear pump that is being used a lot in hydraulics. Then the other question, sometimes it depends on the system. If it's a mobile system, you use an internal combustion engine, most times that runs on diesel. But if it's a stationary system, you use the electric motor as the prime mover. Is that clear?
Yes, sir.
Okay, good. Question? Can we proceed?
I have a question. I have
Okay.
a question. So basically, part of the demerit of the hydraulic system, you said that pollution by waste oil. So I want to ask, does
Yes.
the hydraulic system does it have a compartment where oil is stored? If it does,
Oh, good.
how then do you say that it causes pollution? The oil causes pollution. Is it that it is not well regulated? That they didn't make it in a way that it regularizes or it regulates the amount of oil that it uses when it is lubricating the hydraulic system. So why is there a pollution?
Okay. Now, one thing is this. If you work with pneumatics, that's compressed air system, we have what we call exhaust. That exhaust means air that you've used that has been spent. it goes back straight to the atmosphere. But in the hydraulic system, the oil that you've used, you need to change it. Now, that oil, sending it back to the environment after it has been used constitutes what? Constitutes what to the environment?
Pollution.
Pollution. That's it. Is it clear?
Yeah, it is
Like
clear.
if you drain your lubrication oil from your generator, do you keep it inside your freezer?
No, no.
No. Sometimes you pour it in the drains, or you pour it ahead. So that's what we mean by it's a source of pollution. Are we clear on that?
Thank you. Thank you very much.
Good.
Question,
Can we move
question,
on?
sir. Question, please. Question, please.
Okay.
In the aspect of the oil,
Yes.
does hydraulic system have oil detector to know when the oil is due for change, or do you just feel like it's done, it's too late, let's change it, or what? I just want
No,
to
no,
know.
no, no. Now, there are processes, just like what you call service life. When you buy a oil, eh? For those that even work in generator, you know that this oil is due to be changed after what? Probably 250 hours or 200 hours of use. And that's why it's good to keep a log. So the manufacturer of the oil will specify for you that this is the service life of this oil. Though. After so number of hours, this oil is due for change. Or sometimes company also have their own standard that once we buy this oil, not even some are even more stricter than the manufacturer, that after so amount, or we notice this, the oil is due for replacement. Is that okay?
Yes, sir.
Are we good to go?
Yes, sir.
Okay, I'm enjoying the way you're asking questions and interacting. So now, we want to look at some basic principles of hydraulics. The first one is the base thing about hydraulics is pressure. And how does pressure occur? There's what you call flow and there's what you call pressure. They are two different things. Flow is the fluid moving. Like when you start the pump, the fluid flows, but pressure has not resulted. Pressure results when there is resistance to that fluid flow, or to a force, or there is resistance to the force that attempts to make the fluid flow. So pressure occurs when there is resistance to flow. So get the difference between flow and pressure. When there is resistance to flow, then pressure results, or to the force, and when there is resistance to that force that tends to make the fluid flow. And the resistance comes manifest in three ways. One, when there is load on the actuator. Actuator means devices that carry out work in hydraulics. When there is no work to be done for them, pressure does not result. But immediately you mount a load on that actuator, pressure will result because it will try to resist that. Now, another thing is orifice or restriction in the piping of valves. When you make a pipe at one point smaller, at another point bigger, or you create orifice for the fluid to move, you don't allow the fluid to also move freely. It means you're also resisting the flow of the fluid. That's another way of generating pressure. And the third one is dependent on the density or viscosity of the fluid. We are talking about the internal capacity, the internal property of the fluid. If you look at palm oil now and you look at water, palm oil is more viscous than water. So therefore, you say for a certain volume of water and for a certain volume of palm oil, the weight of the palm oil will be higher than that of water. So that is dependent on the weight of the fluid. So I've said there is a difference between pressure and flow. Flow is the movement of the fluid, but pressure occurs when there is resistance to that flow or to the force that tends to make the fluid flow. And that resistance manifests in three ways. When there is a load on that actuator, the actuator will try to resist that load, so pressure result. Or when you restrict or you create orifice in the piping, it means that the pipe will have, at some point they will be smaller, at some point there is a curvature, at some point there is a bend, pressure will result. And the third one is based on what? The density of the fluid. Now, that leads us to this important principle, which is called Pascal's law or Pascal's principle. And what is it? When you apply pressure to a confined fluid, that pressure travels in all directions, and that with equal force and unequal areas, and is at right angles to them, meaning that pressure is force acting on a unit area, and it is expressed based on the name of the man, that's Newton per meter, which is equal to 1 Pascal. It means 1 Pascal is equal to 1 Newton per meter squared. That's Pascal's principle. In fact, it is Pascal's principle that forms the foundation of hydraulics. That when you have a fluid and you confine it in a particular space and you apply pressure to that fluid, that pressure travels throughout the fluid equally, and is the same pressure that acts on equal areas. So that is Pascal's law, or what you call Pascal's principle. The full name of Pascal is Blaise Pascal's law, Blaise Pascal. So you may also see it as Blaise Pascal's principle of hydraulics, or Blaise Pascal's law, or Pascal's principle. It is this principle that forms the foundation of hydraulics. Now, another concept is that, before the other concepts, how do you measure pressure? Now, there is a standard, and the standard is the weight of the gases on the atmosphere, and that is why the ATM is used. So ATM means atmosphere. The weight of the gases is taken as a standard everywhere over the earth surface. Now, that 1 atmosphere, so pressure is measured in 3 units: Pascal, in bar, and in pounds per square inch, which you call PSI. So 1 ATM is equal to 1.013 times 10 raised to power 5 Pascal, or 1.013 bar, or 14.7 PSI. It is not for you to cram this figure, but it's for you to also know that Pascal, the pressure is measured in bar, it is measured in Newton per meter square, it is also measured in Pascal, or pounds per square inch. The main thing is for you to see that when you are reading a pressure gauge, you may see Pascal there. Sometimes you may even see megapascal. You see bar and you see pounds per square inch. In secondary school, we learn about mmHg. Most time in the industry, you may see some pressure gauge expressing that, but usually what you have is the Pascal, the bar, and the pounds per square inch as the unit of pressure. Is that clear? Mr. Sunday, Mr. Falana, Miriam,
Yes.
are you learning?
Sorry, what? Yes, we are hearing
Yes.
you
Yes,
loud
okay,
and clear.
good. I just want to confirm. Now,
Okay.
we measure pressure. Another thing we also... Hello?
Let's not go tomorrow. Why is the cloth wet?
The other parameters that we also measure in hydraulic is the velocity and the flow rate. Now, velocity is just the average distance the fluid travels per unit of time. That's velocity. Now, flow rate, on the other hand, is amount that's related to what is the volume of this fluid passing a given point in a given time. These two parameters are very important in hydraulics: the flow rate and the velocity. So flow rate is the volume with respect to time, and the flow rate is measured in meter cube per second, or when you have large amount, liters per minute. So when you look at a point in the hydraulic system, what is the amount of fluid that is flowing at that given point? Or what is the speed traveled by the fluid particles with respect to time? That is, these two are the two other parameters that are very important. Now, another principle in hydraulics is continuity of fluid flow, and it states that what? The velocity of a fluid passing through a pipe increases as the area of the pipe decreases, and decreases as the pipe area decreases. It means when you have a large pipe, pressure is large and velocity is reduced. And when you have a smaller pipe, the fluid flows faster. That means the velocity increases and the pressure decreases. That is the principle of continuity of fluid flow in hydraulics. Now, we look at types of flow in hydraulics. Before the types of flow, I will show you this. You can see what we call, from this diagram, before I go back to the explanation, you can see what we call laminar flow. You can see something smooth. You can see a line. You can see the arrowhead. Then you can see what we call turbulent flow, that the molecules of the fluid are moving in an haphazard manner, in a manner that is not ordered at all. Now, so what is laminar flow? Laminar flow occurs when the fluid moves in parallel flow paths or ordered cylindrical layer, and it occurs at low velocity. That's usually between 2 to 6 meters per second. That's laminar flow. Laminar flow is also called uniform flow or streamlined flow. That means the particles are moving in an orderly manner. Just like when you queue in the assembly and you are marching to your classes in an ordered manner. That's what laminar flow is. Everything is ordered. The only thing with laminar flow is that the particles in front, they tend to move faster than the particles that are closer to the wall, but everything is ordered. So you can say laminar flow is uniform flow or streamlined flow. The other type of flow is what you call turbulent flow. Even from that word, turbulent, it means the particles, they don't move smoothly parallel to the flow direction. The particles at the center, they swing to the side, hindering the other particles. So what results in turbulent flow is chaos, commotion. That's turbulent flow for you. Now, laminar flow occurs in straight parallel flow path at low velocity. That means the fluid moves smoothly. The only thing is that fluid particles at the center, they move very faster because the fluid particles close to the pipe wall, they hit the pipe wall and friction results. Then turbulent flow occurs when the particles do not move parallel to the flow direction. The particles move in a disordered manner, as simple. Now you can see from this diagram, you can see laminar flow. The particles are moving straight. Then the particles that are close to the wall are moving slowly. That's why you see the curve. That if you see the three lines compared to the others, it's because they are hitting the pipe wall and friction results. Now, if you look at turbulent flow, you can see everything. Nothing is ordered. Everything is scattered. Now, there is a reason why turbulent flow occurs. And turbulent flow also is not good for the hydraulic system. It has effect. So, the next slide shows us the causes and effects of turbulent flow, and we are there now. So, what causes turbulent flow? What creates turbulent flow? When there are sudden changes in the direction of flow, when there is a sudden change in the direction of flow, it will create turbulent flow. Another thing is also when there are sudden changes in the pipe cross-sectional area, turbulent flow results, or by very high velocity, above 6 meters per second. I've told you that Laminar flow occurs at 2 to 6 meters per second. But turbulent flow, when it's greater than 6 meters per second, that's the critical velocity, then turbulent flow will result. So going over it, turbulent flow will result when there are sudden changes in the direction of flow, sometimes bends, or when there are sudden changes in the pipe cross-sectional area. You have probably a 4 mm pipe, then suddenly at one point you just change to 10 mm, turbulent flow will result. And when the fluid flow velocity is above the critical velocity, which is 6 meters per second, turbulent flow is called undesirable flow. It is not desirable at all in the hydraulic system. Why? Turbulent flow will cause an increase in temperature. Why? When the particles move around and they swing and they hit the pipe walls, friction will result. And once there is friction, heat will be generated. And once it is generated, the molecules gain kinetic energy, and so that it leads to what? Increase in temperature. Then, when there is increase in temperature, the fluid starts losing, as they gain more kinetic energy, the bond is broken. They start becoming light. And once the fluid becomes light, power is wasted. It results in pressure losses in the hydraulic system. Another effect of turbulent flow is what you call frothing, bubble formation. Bubbles begin to be formed because the liquid is getting heated up and bonds are being broken and molecules are gaining kinetic energy. They are going into gaseous state. Another effect of turbulent flow is what you call cavitation. Cavitation is a combination of factors. That is, when the liquids become atomized and there is heat, suddenly explosion will occur. And when explosion occurs, part of the cavitation will occur, which is wearing away of the hydraulic components. You have wearing away, and this will lead to particles being dissolved in the fluid and as well creating uneven surface for the movement of the hydraulic fluid. So are we clear about types of flow now? I need responses.
Yes.
Or you want me to go over them again? Because turbulent flow is not ideal for the hydraulic system at all. That's the essence of, that's why focus is more on the turbulent flow. The laminar flow, you see, police will not go around arresting law-abiding citizens. That's what the laminar flow is. But criminally minded people are what the police will focus on. That's why there is a lot of emphasis on the turbulent flow. Are we good to go? So now I want to talk about hydraulic fluids.
Question, sir.
Fluids, yes?
Question, sir.
Okay, good.
Please, sir, I want to ask question on that turbulent
Flow.
parameter.
Okay.
Now,
That's,
when it occurs,
yes.
that turbulent, when it occurs, let's take it for example that we are using the internal combustion engine to propel or to pressurize the
Drive your
liquid.
hydraulic system.
Yes.
Yes.
Once it happens, is there a throwback effect to the combustible engine? Maybe defect or problem that turbulence will cause. Because in your statement you said if there is change, maybe in the cross-sectional area of the pipe involved, it will result to turbulent flow. I said, will it have a bad effect to the combustion engine that is propelling the whole hydraulic system?
Most times, the problem will usually start from the system. And another thing is, it depends on the connection of your pump. If it will, the turbulent flow will affect your line, but if your pump is properly protected, one way of properly protecting your pump from having back pressure is when you have what you call a check valve or non-return valve. That's one. So you not have back pressure returning to your pump Or in the other case, when you have a pressure relief valve protecting your pump, your internal combustion engine might not really be affected. But if it's an extreme case where the turbulent flow is not corrected on time, then once it gets to your pump and damages the pump, then it's going to affect your internal combustion engine. Is that clear? Are you clear?
Yes, sir. Yes, sir.
Okay. Okay, good. So we can move on. Now let's look at hydraulic fluids. What are the primary functions of the hydraulic fluid? Number one, the hydraulic fluid is to transmit power for the actuators to work. Another function is lubrication. You know, we said hydraulic systems are self-lubricating, so the fluid should lubricate the hydraulic components. Another thing is that the fluid acts as a seal. A seal means that it prevents contaminant, air, and foreign particles from getting into the components in a way that they will not act as contaminants that will cause friction or act as foreign particles that will affect the performance of the entire hydraulic system. Another function is that they cool. Oil cools. So, you know, the hydraulic oil has favorable heat dissipation. So it absorbs heat such that there is no excessive temperature in the system. Those are the primary function of the hydraulics or of the hydraulic fluid. You have power transmission, which is the main thing. The second one is lubrication. The third one is that they act as a seal against contaminant, particularly air and other dust particles from getting into the system, and they also cool the hydraulic system. Now we look at other quality requirements, that is the secondary functions that they do. One is that they prevent rust. They prevent rust of the components of the hydraulic system. They also prevent formation of slimy fluid on the surface of the hydraulic component, sludge or gum, materials that will form on the surface of the hydraulic component or internally that will not allow them to perform properly. The hydraulic fluid should prevent the formation of that. They should also depress foaming, that is formation of bubbles. The hydraulic fluid should be so viscous that unless there are extreme conditions, they should prevent the formation of bubbles. They should also prevent corrosion, that is chemical wearing of the hydraulic components, and pitting. Pitting is physical wearing of the hydraulic component. So majorly, I'll go over again. The purposes of the fluid are PLSC. That's the primary purpose. To transmit power, to lubricate the system, to seal, that prevents entrance of contaminants, particularly air and particles, dust from entering the system, and they also cool the system so that the system functions properly. I said other secondary functions would be to prevent rust, to prevent formation of sludge and varnish, to depress foam, that's formation of bubble, and to prevent chemical wearing of the hydraulic component materials, that's corrosion, or physical wearing, that is pitting. Sometimes some other things they could do is to maintain a stable body over a wide range of temperature, that's to maintain their viscosity or to separate out air from the system. Those are other secondary requirements. Now, so let's look at, still talking about hydraulic fluid. The major fluid that is used is petroleum oil. That's the major fluid that is used in hydraulics. At the start of hydraulics in the earlier centuries, water was used. But you know what water will do? Water will evaporate easily, which means its viscosity comes into question. Then water will also rust, create rust. So what is commonly used is petroleum oil, or what you call mineral oil. And what does mineral oil do? it transmits power readily. Why? Because it is slightly compressible, very difficult to compress. And another property it has is what? It has the capacity to lubricate. Mineral will lubricate for you, but it has one major disadvantage. You know, it's made up of hydrocarbons, so it is combustible. It burns. But now, to improve this, eh, additives are added to the mineral oil. And when additives are added, the property of the mineral oil is improved to make it fire resistant. You improve the quality of the mineral oil or petroleum oil by adding additives. And when you add the additives, it improves its capacity to burn. So it becomes what you call fire resistant fluid. And with this, at high temperatures, the hydraulic oil can perform well for you and give you good performance. Sometimes you have what you call water glycols or phosphate ester or what you call synthetics. But the major thing you should understand here is that petroleum oil is commonly used because it has the capacity for power transmission and it can lubricate, but it is combustible. But to correct that its disadvantage, additives are added to the mineral oil to improve its quality, to make it fire resistant. Are we good? Are we good?
Very good.
Good now. So let's look at an important quality of the hydraulic fluid, which is what? Viscosity. This is a common sense thing. If a fluid has high resistance to flow, you say that fluid is thick. Or in common parlance, some people say the fluid is thick. That means it is viscous. So we say viscosity is a measure of the fluid's resistance to flow or the inverse of fluidity. That means if a fluid flows easily, its viscosity is low. That means it has a thin or low body. Now, viscosity is good. Viscosity is also a problem. You need viscosity to perform lubrication and to perform sealing in an hydraulic system. That's talking about the fluid, but it's also a problem. Viscosity causes friction. So viscosity is key in hydraulics. So viscosity is the resistance of a fluid to flow or the inverse of fluidity. So if a fluid flows easily, its viscosity is low. If it does not flow easily, then its viscosity is high. Now, viscosity is a good quality and it's also a bad quality. So you have to compromise. So you need viscosity to lubricate and to seal, but viscosity also causes friction. Now, we want to look at some effects of very high viscosity. So note the word to qualify it, not high viscosity. There are times you need high viscosity for your hydraulic system to work. There are times you know low viscosity. We are talking about extremes now. Very high viscosity and very low viscosity. So let's look at some of the effects when the viscosity is very high. Not the word, use of the word, not high, very high. That means you are getting to extreme. So the first thing that will happen is the fluid will have high resistance to flow. It will not flow easily. Now, when the fluid does not flow easily, it means to pump the fluid, you consume more power in trying to force the fluid to flow because the fluid is resisting flow. So there will be increased power consumption because you are trying to force the fluid to flow and the fluid does not want to flow. Another problem that will result is high temperature, which is caused by friction. Friction will also result because once the internal particles of the fluid are dragging and they don't, you have internal viscosity. So the fluid does not want to flow easily and you have to drag and drag. Then high temperature will result. That will be caused by friction. Now, apart from that, because the fluid is not flowing easily, you are trying to drag it to make it do work for you, you are going to have sluggish or slow operation. Those are some of the effects of very high viscosity. So there will be, the fluid will resist flow, and because of that you consume power, and when you are consuming power trying to drag the fluid, as you are trying to drag the fluid, the layers of the fluid will be working against one another, which will create friction. Now, when that results, because you are trying to drag the fluid to flow, you have sluggish or slow operation of that hydraulic system. Now, let's look at some effects of very low viscosity. Emphasis on very low viscosity. Now, if you use your hand and you pour a viscous liquid on your hand, sometimes your cream, you see that the cream will stay in your hand, even across your fingers. But if it's a oil or something, it will go through your fingers. So likewise, in an hydraulic system, you'll be having excessive internal leakage because the body of the fluid is low, it is thin, it will not congeal, it will not hold together. Now, another problem that will result once there is no lubrication, you have excessive wear. Sometimes there won't be session. Session means your hydraulic system will not run, it will get stuck. Just that when you have your blender and you pour probably your contents into the blender, and at some point the blender will not roll, that's what you call a session. So it means you have to pour more water for the blender to roll. So it will create excessive wear of the hydraulic component, or it will create what you call sometimes a mechanical lock. That means under heavy load, the system will not move at all. Now, another problem that will result is when you look at efficiency, efficiency is the ratio of your output compared to your input. Because the fluid has a low thin body, your pump will just keep pumping and work will not really be done. So your pump, it's as if your pump is not working at all. So that what causes pump efficiency to decrease because you have a lot of friction in the system. So a lot of the energy that is required to work is lost as friction. Another problem is increased temperature. Once you have friction, definitely temperature in the system will increase, and there is no lubrication as well. So temperature will increase where you have very low viscosity. So that's why we say viscosity is a compromise. You have to check very well that your viscosity of your fluid is appropriate for your system. It's not very low, neither is very high. So any questions? Any contributions? We dealt with the fluid. We dealt with flow. From laminar flow, we move to the quality of the fluid. I will talk about an important property of the fluid, which is its viscosity. Then we talk about the effect of very high viscosity and the effect of what? Very low viscosity. Are we good? I'll pick someone to
Question,
just
sir. Question,
question.
question, sir.
Okay, good.
From Ume Enugu, please, sir.
Yes.
We talked about the fluid.
Yes.
It shouldn't be highly viscous, and it shouldn't be less or low in viscosity. Now, my
Very
question
low.
comes
Emphasis
Very
on
low.
very high and very low.
because
Yes.
the both factors affect the hydraulic system. Now,
Yes.
is there any gauge? Is there any gauge to or standard? Let me use that word standard to show that this is the standard of viscosity needed for hydraulic processes, so that whenever we are going for liquid, we say, okay, this liquid is meeting the standard of the particular liquid flow we need. That's my
Okay,
question.
good.
Is there anything like standard?
Okay. Now, it depends on, also, when we talk about lubrication in vehicles, one oil that will work for a vehicle may not work well in another vehicle. Are you getting me? Now, depending on the application and the OEM, that's the equipment manufacturer, there are specifics about the viscosity. There is a device called viscometer, or sometimes you can do inspection to know that this oil, they are recommended oil for particular applications, that this oil in its capacity of production is good for this particular system. Are you getting me? It depends on the application. You get it?
Yes, sir.
Okay. So now we move to a core unit. I know somebody has asked question about this. So we want to talk about the hydraulics power supply unit. And I think probably that's where we're going to stop today. Or if you want more, we'll go more. So this is now for the hydraulic system. The hydraulic system is actually divided into 3 units. The first unit is the power supply unit. The second unit is the power control unit. And the third is the drive unit. I'll take that again. The structure of the hydraulic system is divided into 3. 1 is the power supply unit. 2 is the power control unit. And the third one is the drive unit. I take it again. The first one is the power supply unit, where power is generated. The second one is the power control unit, where you control the power that is being generated. That's where you have the valves. And the third unit is the drive unit. That's where you have your working devices. So we now look at the hydraulics power supply unit. So as you can see from the picture, you can see the electric motor, you can see the hydraulic pump, you can see the pressure reliever installed parallel to the hydraulic pump. You can see the pressure gauge attached to the pressure relief valve. And you can see the tank. The pump pumps from the tank. So what are the main components? Now, if you are using an internal combustion engine, oh, okay, good. I've said it there. So if you are using a mobile unit, then the internal combustion engine will drive your pump. So let's look at the main components. We now take them in one order. So the main components are the electric motor or the internal combustion engine. That's to drive the pump. The second one is the hydraulic pump. The third is the pressure relief valve, which protects the pump. Then the third is the tank, or what you call reservoir. And the final one is the filter. The filter is for separating impurities. So now we look at each one. So the first one is the electric motor, or it could be an internal combustion engine. So the electric motor drives the pump. Somebody was asking a question at the other time. It is the prime mover of the pump. So it powers the pump to work. So that's the function of the electric motor. The next one is the hydraulic pump. Now, the hydraulic pump actually creates flow. It draws the hydraulic fluid from the reservoir or tank. Now, but when it draws it, the liquid will flow. But the liquid flowing, it will meet components along the way. It will meet resistance. It will meet components that will prevent it from flowing. And that's when pressure is generated. So that is how the pump generates pressure energy needed by the hydraulic system to work. The pump actually creates the flow. It draws the hydraulic fluid. But once the hydraulic fluid meets resistance along the way, pressure is generated. So in a way, the pump also generates the pressure energy needed by the hydraulic pump. And look at the symbol of the hydraulic pump. You can see that triangle. That triangle faces up. So be careful to note that, because there's another symbol that resembles that, but this triangle faces up. That's the symbol of the hydraulic pump. Now, the pressure relief valve. From that word, even relief. When you say somebody is relieving you, that person is helping you. The pressure reliever is a safety device. It protects the pump from overpressure. It protects the pump from overpressure. So when there is excess pressure that is being drawn from the pump beyond the capacity of the pump, the pressure reliever will act to protect the pump from damage. And usually you attach a pressure gauge to the pressure reliever to monitor the pressure that it's working with. Now, that's the pressure reliever. From that word relief, that means it is also called pressure limiting valve. The pressure reliever is called pressure reliever, pressure limiting valve, or safety valve. Its job is to protect the pump from overpressure. When the system demands excess pressure, the pressure reliever will act and take the excess pressure back to tank and thereby protecting the pressure. Not only that, also along the line too, you mount the pressure reliever also to protect the system. Now, the tank or reservoir. The tank or reservoir. We have what we call open tank or closed tank. The open tank has a way of being vented to the atmosphere. It has what you call aeration valve. So that's why you call it some people call it vented reservoir. And the tank that is not vented to the atmosphere is called pressurized reservoir. So some people call the vented reservoir open tank, and they call the pressurized reservoir a closed tank. Not that the open tank is just open. It has an aeration valve that allows escape ventilation. So, but what are the functions of the tank? The functions of the tank are three: SSC. SSC. One, storage. The tank is for storing the hydraulic fluid. That's where you keep the hydraulic fluid before the pump draws the hydraulic fluid. Then the tank also has a separating unit. What do you mean by tank as a separating unit? It separates impurities. So when the fluid returns from the line, the fluid will settle. So impurities will settle at the base, and the oil at the top will be clean. So that is how the tank acts as a separating unit. And finally, the tank does the job of cooling. You know, the body of the tank itself is a material. So the heat that comes from the hot oil in the system goes to the tank. So if you already have a cool hydraulic oil in the tank, heat is being exchanged, and the heat will be absorbed by the tank, and it will be sent to the atmosphere. That means the tank itself will exchange heat with the atmosphere. So that is the work of the tank. Finally, the filter. Now, the filter can be mounted before the pump, it can be mounted along the line, and it can be mounted on the return line. That means going back to tank. So I say it again, that the filter can be mounted before the pump, on the line, and on the return line. And what is the function of the filter? Just to separate impurities from the oil. But the technical word we use is contaminants. Contaminants. Eh? Rather than say impurities, we say contaminant. And that's the symbol of the filter with dotted line in the middle. So those are the main components of the hydraulic system. Now, time to review the hydraulics power supply unit. So I want one of you to read what is on the slide to see that I want to review the hydraulics power supply unit. Yes, who volunteer? Is it the man from Enugu, or the man from Ibadan, or Sunday, or a
Yes,
lady?
a man from
Anybody to
Enugu.
volunteer?
A man from Enugu.
Okay, good. Like this man likes hydraulics like anything. Okay, good. Do the review.
Hydraulic system in waste management. Review of hydraulic power supply units. The electric motor powers the hydraulic pump. The hydraulic pump, it creates the flow of the hydraulic fluid to the drive section. The pressure relief valve, it is a safety device used to protect the pump from damage caused by excessive pressures. The tank or reservoir, it has three uses. Storage, number one, storage of the fluid. Number two, separating unit for separating contaminants. Number three, cooling of the hydraulic fluid. The filter, used for separating contaminants from non-contaminants. Thanks.
Thanks so much. Okay, a man has done it. I want a lady to also do this review, at least.
Okay.
Good. Introduce yourself.
Okay,
I
I'm
suspect
Choma
that's Chioma.
Okafor. I'm Choma Okafor from Lagos.
Okay, good.
So I system in waste management.
Yes.
Review of the hydraulic power supply unit. The electric motor, it powers the hydraulic pump. The hydraulic pump, it creates the flow of the hydraulic fluid to the drive section. The pressure relief valve, it is a safety device used to protect the pump from damage caused by excessive pressures. The tank or reservoir, it has three uses. Number one, storage of the fluid. Number two, separating units for separating contaminants. Number three, cooling of the hydraulic fluid. The filter, used for separating contaminants from non-contaminants.
Oh,
Thank you.
thanks so much. You go have been doing wonderfully. Now, the these are the main components of the hydraulic unit. These are the main components of the hydraulic unit. There are other accessories of the hydraulic unit. Eh? So I need another person, apart from Chioma and the man from Enugu, to also read the other slide, this slide particularly. Other accessories of the hydraulic, they are not the main ones, they are just accessories, but we have dealt with the main components. So somebody else to volunteer,
Hello,
you introduce yourself.
my name is Sylvia Odunota.
Okay,
Hydraulic system in waste management. Other accessories of the hydraulic power units are the oil conditioners, the heater for heating the hydraulic oil, the cooler for cooling the hydraulic oil, the indicators of power supply units for pressure, the pressure gauge for temperature, thermometer for level indicator for flow meter.
thanks so much. That's wonderful. So let me briefly discuss it before we see the symbols of this. In this course, you will encounter a lot of symbols, but don't worry, you get to at least recognize some of them and try and
You cannot write
over
am.
time. Yes,
You cannot write.
if
Go
you
and
want to
take
write,
water.
write now.
Read and flush it
Nobody
out.
is stopping you. Now, the oil conditioners, from the word condition, eh, there is a local balance that is condition that make crayfish burn. We can also condition our oil when there are extreme temperatures. So when the oil congeals, eh, you have a heater attached to the hydraulic power supply unit. You can heat up the oil so that the oil can give you good performance. And at the same time, when the oil is also too hot, you can also condition it. You can cool the oil. From the symbols, you see that the heater brings heat into the system when we get there, and the cooler takes heat away from the system. Then, in hydraulics, our major parameter is pressure. So you need the pressure gauge to monitor pressure at every point. It's very important. At different points of the hydraulic system, you need to mount pressure gauges to ensure that you are really working safe. Then, so your thermometer will also help you to read the temperature to know that I know that most people are complaining about it. A lot of people are feeling uncomfortable. So just like that too. So you need to monitor temperature, then you can condition your before you condition your hydraulic oil. Now for level, you have a level indicator to know the level of the oil in your system. And most times it's good to keep your tank filled so that you can expel air from the system and also expel moisture. And another thing is flow meter. You want to know how far the amount of fluid that flows per unit of time. So now, these are the symbols of the heater. So you can see the heater brings heat into the system. You can see a line between and you can see the arrow. Then the other one, the cooler, is the opposite. It takes heat out of the system. The cooler takes heat out of the system. Can we understand these symbols now? One brings heat into the system, the other one takes heat out of the system. Now let's look at the indicators. You can see the symbol of the pressure gauge. Then the symbol of the flow meter. The flow meter resembles a tennis ball. Then you can see the level indicator. You see the two lines in, like showing the level. Then you can see the thermometer. If you remember your mercury in glass thermometer, if you notice something for your conditioners, you are seeing the symbol, looks like the symbol of a kite. Then you now have a line at the center, so you don't need to cram this. It draws it into the system. And the other one, it takes it out of the system. Now, for the indicators, observe that all the indicators have a round what? They have a round shape. For the pressure gauge, you can see the dial. For the flow meter, you can see two curves. Then from the level indicator, you can see the two lines. And from your thermometer, you can see the mercury in glass embedded inside the circle. So those are the accessories that are attached to what? The hydraulics power supply unit. Now, time for quiz. Time for quiz. And so you answer, time for quiz. And the aim of the quiz is to test yourself and check if you have really learned. And learning is beautiful when you make effort. So don't make attempts. Make attempts. So list 3 units of the hydraulic system. I need someone to answer this. List 3 units of the hydraulic system. I need someone to answer.
Hello, sir.
Yes.
The power supply unit,
Yes.
the control unit, and the drive unit.
So those are the 3 units of the hydraulic system. Now, from this question, I will ask another question. So I want someone else. What is the function of the power supply unit? I need somebody to give me an answer.
It provides energy and drives the pump.
Okay, good. It provides pressure energy or power to the hydraulic system. Now, the power control unit, another person, what is the function of the power control unit? Answer. Function of the power control unit.
Yes, sir.
Yes.
The power control unit acts as or like a regulator
Good. I love that word,
for
regulator. That's where you have the
yeah.
valve. It's from the word control. Beautiful. And finally, the drive unit. Another person. the drive unit. Oya Fisayo, Mariam, please do justice to this question. Are you still with us?
Yes, sir.
So what's the function of the drive unit?
Uh,
Try.
the drive unit is where
Where the work is done.
yes,
The drive
yes,
unit
sir.
are called actuators. That's where you
Yes,
have devices that you call cylinders or hydraulic motors. And later we'll go into that. That's where the work, there are
the work.
devices that do the work. Is that clear to everybody? So now, question 2. What are the main components of the power supply unit? Someone to answer that?
Let me try,
The
sir.
electric motor. Okay.
Okay.
Let me try. The main component of the power supply, let's take the electric motor as the
Yes.
prime mover. We have a router there
Uh-huh.
that tries to turn the couple that joins the shaft that comes from the pump and the connecting shaft. Maybe
Yes.
the router is one of the components of electric motor.
Yes. Continue or somebody will help you out.
Okay, I said the one
How
of the
about you?
prime
You
move.
said electric motor, internal combustion engine. That's to
Yes,
power the pump. You mentioned the
yes,
hydraulic pump that
yes,
generates flow, that creates pressure in the system. Then you now stopped.
yes.
Or is it your network? So someone can complete. He has mentioned the prime mover, which is the internal combustion engine or electric motor. He has mentioned the pump. What are the other units?
The third one is the pressure relief valve,
Yes.
which is also a safety device for protecting the pump.
Beautiful. Eh. Another person or you continue. One more thing.
Another one is the tank and all the reservoir.
Good. Beautiful. It's like you are getting the concept. Beautiful. Good. Now there is a link here that you can click or you watch to get a better understanding of the hydraulic power supply unit. At least on your own you can get better informed. So uh, well, I want to just introduce you to the power control unit. We will soon stop. I want us to stop at this point. So that we'll do the power control unit and the drive unit tomorrow. But let me introduce you to the power control unit.
Question, sir.
Yes, question, yes?
Please, I want to ask two questions, but they are in
Good.
one. One,
Yes.
does hydraulic system fail? If it fails, what leads to the failure of the hydraulic system?
Okay. Now, I will say there is no system that cannot fail. That's number one. There is no system that cannot fail. But what are the causes of those failure? The causes could be human. Most times it's usually human. When I say human, that somebody did not uh, follow standards in using the hydraulic system or what is required for a particular hydraulic system. That's one. Now, what are those things that could actually cause failure? Number one is the fluid. Now, what do I mean by the fluid? If the service life of the fluid is over and you fail to replace it, there is going to be trouble. That's one. Another thing with the fluid is if you use the inappropriate fluid or you mix fluids. Okay, this one should work it. That will be an issue. Now, again, replacing the fluid does not mean that the service life is over. Probably because of contaminants in the system. Probably the filter was not changed, or the pump is getting bad, and the hydraulic system is not properly worked on. Then the fluid can also be bad, can also go bad before the replacement time. That's one. That's from the fluid angle. Another point is maintenance. What do I mean by maintenance? If there are standard operations and procedure to maintain the hydraulic system, probably check the pump, maybe after every 3 months, check the pump, replace the filter, check the power connection. Probably it's a three-phase pump that's being driven by three-phase power, and you need to check the motor. Probably there is an issue, or the motor is getting hot, and you don't do those things. Or your internal combustion engine that drives needs to be lubricated. You don't perform those checks, then you are going to have issue. Another one is malfunction of your hydraulic component, the valves. Because when you buy valves, they have pressure rating. So if the pressure rating of your valve does not conform to what you are using in your line, or to what is specified by the manufacturer, you are going to have issues. You understand? And another problem that could also result in the failure is also during maintenance. Like during maintenance of an hydraulic unit now, you are supposed to switch off all power, whether electrical, whether hydraulic. And when you switch off, you are supposed to relieve all pressure when you have all the pressure relief valves. Because after you do your maintenance and you just turn on the system suddenly, or during maintenance, there is oil, pressurized oil trapped in the system, it can lead to failure. So you need to do those maintenance checks before you start even your maintenance. So you relieve from all ports and make sure that all actuators are in rest position. So those are among the few things that could cause the failure of the hydraulic system. Is that clear?
Yes, sir. Yes, sir.
Good. Are you good?
I'm good to go, sir.
Okay, so let's just do what I'm seeing is briefly the power control unit. Majorly, they are valves. And what are valves? They are valves valves are devices for controlling energy flow in a hydraulic system. Your valves will control pressure, flow rate, and the direction of flow. Valves are devices for controlling energy flow in a hydraulic system. So types of valve in a hydraulic circuit are: 1, directional control valves, non-return valves, flow control valves, and pressure control valves. Valves are like switches that turns on a light at home. So that's what the power control unit deals with. So I'll introduce you to the directional control valves, then we'll stop here. So they are valves for controlling direction of flow of the hydraulic fluid in the system, and they have a particular naming system. That means to name the directional control valve: number 1, the number of ports, that's number of openings. Number 2, the number of switching position, that's the number of boxes. Number 3, the direction of flow, which is based on the supply port on the right hand side of the valve. And finally, type of actuation and reset on the valve. Actuation means a means of operating the valve. Reset means a means of returning the valve to its original position. So if you look at this, you can see valve actuation mechanisms. Push button, the mechanical, foot pedal, you have hand lever, you have pneumatic pilot, you have hydraulic pilot, and you have solenoid. Then, if you see on this picture, you have almost the same thing, except now for return, you have the hydraulic pilot. You can also use the air pilot, you can use solenoid, and you can use the spring. So, at this point, I want us to stop for today. Or you want to go more? I want us to stop for today. What do you think? I need responses from you.
Yeah, let's continue tomorrow, sir.
We should continue. Tomorrow is public holiday. I think the next one should be a Thursday from the timetable. Tomorrow is Workers' Day.
No problem, sir.
Okay. So let's look at all that we covered today. We discussed the hydraulic system. That's using pressurized oil to do work. Not only that, we talk about the merits of the hydraulic system. Talk about merits of the hydraulic system, that the hydraulic system is a force multiplier, can be started under maximum load, and that motion is smooth and even and can easily be reversed. We talk about its demerits, the demerits of the hydraulic system, that oil attracts dirt and waste oil causes pollution, and there is the danger of excessive pressures. Then from there, we talk about some basic principles, which is pressure, and pressure is not flow. Pressure is resistance to flow, and that resistance can be generated by load on the actuator, restriction or orifice in the piping of valves, and the weight of the fluid. We talk about Pascal's law, and Pascal's law says when you confine a fluid in a space and you apply pressure to that fluid, that pressure is transferred with equal force on equal areas, and that is where we have pressure is force acting on a unit area. And this is named after Blaise Pascal. That means 1 Pascal is 1 Newton per meter square. We discuss the unit of pressure as Pascal bar and pounds per square inch. Then we talk about velocity. That's the average distance the fluid particles travel per unit of time. And flow rate is the amount of the fluid that passes a given point in a given time. Then we talk about the principle of continuity of fluid flow, that in a narrow pipe, the velocity is high, and in a large pipe, the velocity is low. Likewise, in a narrow pipe, pressure is low, and in a large pipe, pressure is high. We talk about types of flow: laminar, or what you say streamline or uniform flow, where the particles move in an ordered manner, and the particle at the center move faster than the particles at the side. Then we talk about turbulent flow, which is the disordered type of flow. And we look from this diagram, we look at, we can see it. Then we mention turbulent flow, what causes turbulent flow and its effect. And when you say there's a sudden change in the cross-sectional area or in the direction of flow, or by very high velocity above 6 meters per second. And we say turbulent flow is not ideal for the system because it causes increase in temperature, it causes pressure losses, cavitation, and bubble formation. And we talk about the hydraulic fluid that it has 4 functions: PLSC, power transmission, to transmit power, to lubricate the component, to act as a seal from air and dirt. Then it also cools the system. Then its other function to prevent rust, to depress foaming. Then we talk about the fluid that petroleum is used because it transmits power easily and it can lubricate. but it has a problem that it is combustible. And that is what created fire resistant fluid. When you add additives to the mineral, you improve its quality. Then we talk about viscosity. That viscosity is the inverse of fluidity. So when a fluid body is low, it means its viscosity is low. When it is thick, its viscosity is good. Viscosity is useful to lubricate and seal, but it causes friction. We discussed the effects of high viscosity, that's high resistance to flow, increased power consumption, and sluggish or slow operation. And for very low velocity, we talk about excessive internal leakage. We talk about wear, oscillation under load, and that the pump efficiency decreases. Then we move to the power supply unit, and we know the main components, which is the electric motor or internal combustion engine, then the pump and the pressure reliever, the tank or reservoir, and the filter. And these are the symbols. Then we talk about the other accessories in the system, which are the conditioners, the heaters and coolers. Heaters take it out of the system, brings heat to the system, and the coolers take it out of the system. And we mentioned the indicators, the pressure gauge for pressure, flow meter for flow rate, level indicator to indicate the level, and the thermometer. Then we did a review, and we talk about the power control unit, where we have valves. They are devices for controlling energy flow in the system. I will mention two types of valve in the hydraulic circuit: directional control valve, non-return valve, flow control valves, and pressure control valves. Then we talk about directional control valves, that there are four key things: the number of ports, the number of switching positions, the direction of flow based on the supply port, and the type of actuation and reset. And we watch this, saw this type of actuation and reset. So at this point, um, I think I'll move. So if you have any contribution, anything, can interact. Yes, Mr. Falano, yes, you can talk.
Okay, is it possible, sir? Well done, sir,
Yes.
for the presentation so far. It has
Okay,
been
thank
quite
you.
instructive.
Thank
Is it
you.
possible to get this slide after this this lesson?
Yes, it will be made available. To be made
Oh,
available. Yes.
okay.
Any
Thank
other
you.
person? Ume?
Hello, sir.
Yes.
Please, my name is Umenu Achisom from Enugu.
Yes,
I
sir.
want to make a plea,
Okay.
because I'm not in Lagos right now.
Okay.
I'm not in Lagos right now because as at last week, I begged the female facilitator that I don't know how they will schedule this in-person program. Maybe work on hands-on practice in IT.
Okay.
So I don't know how we'll do it. Me, I'm only begging. If we can shift it to next weekend, then let me look for money and come to Lagos for that. Don't know if
Okay.
that will be possible. I'm
I
only
think
begging.
the practical is scheduled for, we have a class on Thursday. The practical is scheduled for Friday and Saturday. So, and it's going to be like this from my end. Some people can come on Friday, they are free, and the others that are not free, so that we can do things properly, come on Saturday. Are you getting it?
Yes, I'm with you, sir.
Uh-huh. Yes.
So my point is that I am not in Lagos right
Okay.
now. I'm in Enugu.
I think I will speak to the coordinator of the program, and or probably we'll talk about your case, and they will get back to you.
Okay, sir. But
About
what I'm suggesting is,
yeah,
if the practicals can be shifted to next week, Friday and Saturday,
to be
I will try and raise money and come to Lagos for that particular program. After that, I will go back.
okay.
That's
Okay.
my own
Okay. Yes,
begging.
Mr. Ogunjobi.
Yes, can you hear me, sir? Hello, can you hear me?
Mr. Ogunjobi, sorry, we can't hear you.
Yeah, can you hear me now?
Yes, we can hear you now. Yes.
Yes. I'm also supporting the motion. If the practical session this weekend can be shifted to next weekend, it will be so much appreciated by me as well, because of certain encumbrances on my own part as well this weekend, this coming weekend. I also want to sue that if you can help us to make the recordings available and the
Okay.
PowerPoint as early as possible, possibly even this evening after this lecture. I will so
Okay.
much appreciate it, because I've been facing a lot of disturbance in the course of the lecture.
Oh, okay. I can hear some noise as well. No problem. Yes. Any other person? Please, people talk. Oh. People have expressed their mind. At this point, if there are no further questions or concerns, I want to say thank you for everyone's participation. Eh? Thank you so much. Then sorry for what happened at the beginning. It was some technical glitch with our network. Please pardon us. But any other concern, any other question, so that we call it a day.
Let me ask this question, sir.
Eh?
Let me ask this question, sir.
Okay.
Since we use hydraulic principle in compacting of in compartment or in compacting of waste products, my question
Yes.
goes this way: in designing of compactors,
Yes.
are there specific material that the compactor need to compact? If yes, is there need to install a sensor so that if the material that is not needed in that compartment environment comes in, the compactor will not function, it will trigger a signal showing that this particular object is not
Yeah.
from here?
There are two things in waste compaction. For now, there are times you compact several materials, and there are times you sort the material. Probably it's paper, you compact paper. If it's what do you call it, plastic, you compact plastic. And there are also places where they are not separated. It means before all these things are done, sorting, you have sorting machine. Sorting could have been done depending on what uh, the waste management process is focused on. Eh? Based
Yes,
on
sir.
that facility, depends on what the facility focuses on. Is that clear?
Yes, sir.
Okay.
So what you are saying invariably is that there is nothing like sensor technology involved in hydraulic process.
No, what I'm saying is it depends on the facility that is built, what that facility is meant to do. If it's just purely compacting, then they may compact all garbage without sorting. If they have sorting system, that means they will sort plastic, sort paper, sort compost materials before compacting, or sort metal. There are sorting processes in waste management cycle, but it depends on what the facility that is designed is handling.
Thank you very much, sir.
You're welcome. We can call it a day. You can start leaving the network. Thanks so much and enjoy the workers' day.
Sorry, Mr. DJ, before
There's
you,
an announcement.
yes, please.
Okay, please listen to Mr. Abiola. There's an announcement for the class.
Good evening, everyone.
Good evening, sir.
Yeah, so, okay, wait, let me, I think the class is over. I think I will just stop the recording.
Yeah, the class is over.
Yeah, I'll stop the recording and we talk.